Okay, so let's see a couple basic rules about radicals. So the symbol for radical is this over here. The radical is also known as the square root. And the way it works is it takes the number that's in here and it looks for even powers of this number. So 4 is actually 2 squared. So the radical of 4 is actually the radical of 2 squared. And what happens when it finds an even power is it divides it by 2. So what you're left with is really 2 to the power of 2 divided by 2, which is 2 to the 1, which is 2. So what happens is you can take out any even power from the radical by taking the power over here and dividing it by 2 by halving it. Now, a general rule for this is any number to the power of, um, I don't know, k, it square root becomes a to the power of k over 2. So if k is an even number, we can actually apply this rule because even numbers are divisible by 2. So an example of this would be 3 to the power of 6 square root. Now 6 is an even number, so what happens is we're left with 3 to the power of 6 over 2, which is the same thing as 3 to the power of 3, and therefore the square root of 3 to the power of 6 is 3 to the power of 3. Now, what happens if we have another number under the square root? Well, square root of a to the power of k times b, if we cannot take half of the power of a number, for example, the b over here, then we leave it the way it is, and we rewrite a to the power of k over 2 times the square root of b. So what we've just done here is we've taken out a to the power of k, but we've left b under the square root. Now, of course, it's true that we could have taken out the b because b is actually to the power of 1, and we could have written this as a to the power of k over 2 times b to the power of 1 over 2 because we can write 1 divided by 2, but we are satisfied at this point. We're satisfied if we can take out some even power over here by dividing it by 2 and then leaving the other term under the square root. So if I have, for example, x squared times y cubed under the square root, well then I can say, okay, well look, x is squared. Squared is an even number. I can take it out of my square root by dividing the power of 2 by 2, so I'm left with 1, times the square root of y cubed. Now I can't divide 3 by 2, so I leave it under the square root the way it is. Another rule about square roots is that we can multiply. So if we have two square roots, square root of a times the square root of b, we can multiply what's underneath these square roots together. So when you have two square roots being multiplied to each other, then what you really have is just one big square root where what's underneath the square root is just a times b. So here we had the two square roots separated, and now I joined them together and I multiplied what's under the square root to each other. Now it's true that if I start off with something like this, if I have some number times another number under the square root, I can split it up into two different square roots. And sometimes that's useful, especially if we realize that we can factor out one of these two factors after from our brackets. And I think this is a pretty good start for square roots. Um, we'll look at other properties later on about the square root.